All right, good morning, everyone. Okay, we are live. Welcome to let's make sure I'm unmuted. Yes, we are. Welcome to the 5th episode of SecuriTEA and Crumpets, where we host security professionals each month to talk about different security topics. Today, I'm drinking a nice breakfast tea, so if you're on the West Coast like I am, I hope you will join me for your early morning caffeine intake. Or maybe something a little stronger if you're in other parts of the world. I hope everyone enjoys the next hour or so with myself and our 5th guest. Today, I'm delighted to have Parsia on the show. Parsia is a senior security engineer at Electronic Arts. Parsia has spoken at DEF CON on blockchain hacking and has a wide expertise in hacking games, thick clients, and modern web technologies. Parsia documents most of his brain on his blog, parsia.net, and ramblings on his Twitter, twitter.com/cryptogangster. Welcome, Parsia. Welcome to the stream.
Hey, thanks. Happy to be here.
Great. Well, so this is we were just talking just before we started the stream, and I've known Parsia for over 5 years, and this is the first time we've actually been on a visual camera together, which is quite funny. And obviously, he said first time in the meet space. So this is the man, the myth, the legend, Parsia. So welcome, Parsia, for the next next hour, not that long. For the next hour, I just want to talk about some of the things that you've been doing now, some parts of your history, and then we'll jump into some live demos, and we'll just go from there, basically. Does that sound good?
Sure. Thanks for having me. And if I had my vaccine first dose yesterday, so I have some complications, but I should be fine.
All right. Well, if you need to stop,
If you see suddenly that I'm mumbling random things, don't be alarmed.
yeah, start tweeting EA probably if that happens, because I have no idea what Parsia's contact information is. All right, so let's just talk about EA games for a second. I mean, yeah, we can be alarmed. So you work at EA Games as a senior security engineer. What does the day in the life of a security engineer at EA Games look like?
I don't know. So it's very much like any other product security job out there. You deal with a lot of source code. You deal with a lot of teams. We release, what is it, like 20, 30 games a year, and then probably as many technologies and services. So I do a lot of talking with the developers to figure out how we can fix things. I mean, finding individual bugs is important, but my job as a ProdSec engineer is just eradicating an entire class of bugs instead of just finding one or two things. It depends.
Oh, sorry, I remember I just had myself muted. So let's do that again. So I just asked the question. So you just mentioned about eradicating different types of bugs, and how do you actually go ahead and try and essentially eradicate those types of bugs? What is your process, or what do you do at EA to try and do that?
Sure. So it really depends. At EA, we have a lot of EA specific technologies, we have our own video game engine. So there are ways to misuse, for example, a component in that engine. We go and figure out why it's misused and how we can not do it. If there are correct ways of doing it, we write guidance documents, and then we detect them in code, and then go and say, okay, here's how bad things could happen. Here's how we can fix it without having bad things. And so as a result, that component is just goes away when we're doing security testing. Because now we know if we just check the configuration or source code or whatever, and then now it's working correctly.
I got it. So do you not try, and I guess this is probably a half open-ended answer or question, but do you not try and do defense in depth in these types of things, or is it just because this is sometimes you need to do it that way in a insecure manner, but technically it's in a safe manner because things like input from a user would never be there, for example. Like, how does that really work?
So these are defense in depth is great and all when you are not dealing with a lot of complicated software. Like if I'm dealing with like a static website, then that's easy. If it's like a simple login form, maybe that's easy. But if you're dealing with a game engine that has to create output for like 7 different platforms, then it's really hard to do like things like defense in depth.
Hmm.
Because the priority in a game engine in a video game is working, not if this input is sanitized or not.
I see. I see. So let's just talk about skills for a second. So you obviously have been working at EA for a while now. What were the type of skills that you kind of need to be able to do your job? Like as a obviously probably as a so you used to work at Synopsys or previously Digital,
Mhm.
and obviously you had consulting experience from that realm. And obviously a consultant needs to be able to talk to clients and explain issues, which obviously translates well to developers as well. But what other kind of technical skills might someone need to be able to work in against working in the game industry?
So reading C++ code, because pretty much every video game out there, I mean, with some exceptions, is in C++. Like Unity is a game engine that you write C# code in, but the actual game engine is still in C++. So you need to read that. You need to have to figure out, uh, looking at a bunch of like random protocol blobs going out from the video game and try to figure out what it means. Is it like so you can have to reverse engineering, right? Reverse engineer like custom protocols. Uh, but apart from that, like I mean, if game specific stuff aside, uh, we have to do a lot of like Windows stuff. Uh, the like search like OSCP. Uh, the talks a lot about like privilege escalation and enumerating and all that on Windows. Uh, on a Windows machine, I don't care about it because if your machine is unpatched and there's something bad happens to the game because of that, that's not my problem, right? I have to look at application specific issues and not just like if this patch is there or not. As a result, any of those tools that people use, which are great and have their places, are not useful to me. Like I don't care if I can escalate my privileges using like an OS level issue. I don't care really.
Got it. We had some things in the chat which was talking about understanding classes of bugs, which requires things like variant analysis and then hardening abuse cases at the root level. I think that's kind of similar to what you were talking about previously. And then about also start walking the call flow and following incoming packets. Are you generally like manipulating at the packet level when you're testing games, or are you normally instrumenting the game, which then manipulates the incoming outgoing packets?
Both. Um, depends on the on whatever's I'm testing. Sometimes it's easier to just hook functions using something like Frida or Renap debug to say, oh, send a login request or send request X or request Y. Sometimes when there are tools out there that allow me to like create packets and send them out, I'll just use that tool. Uh, it's easier.
Oh. So that's actually like following on from like you mentioned Frida. Uh, what would you say are good resources would you recommend for someone to take a look at, either tool specific to start to be able to understand how some of the game functionality works, or just in general, like what are good resources in general? And obviously we can
Sure.
link that in the description at the end.
So. Oh, I forgot to say this. The skills you need as a person who's hacking a game from an external perspective, like someone who is not part of the organization, are completely different from the skills you need when you're hacking internally. Like, I don't need to worry about DRM or anti-cheat or anti-debugging or any of these protections. People deal a lot with like bypassing those and then figuring out what the obfuscated binary does. I don't need to deal with that, fortunately, because I have access to source code, I have access to debug builds. I can do those things. I can use those things. So if you're trying to hack a video game externally, the skill set that I have is not going to be useful for you.
Got it. And what would some of those skills be if you do know off the top of your head?
So skills about externally hacking or internally? Sorry,
Yeah,
I was
no, you're right. So yeah, external. So you mentioned obviously internal. It's mostly C++. Obviously being able to, obviously utilizing debug builds and etc. Taking a look at those things. But yeah, just from the outside perspective.
Yeah. Oh, like outside perspective, it's pretty much just your typical malware analysis or reverse engineering job. You have to deal with all those protections like anti-debug, uh, anti-cheat, DRM, um, to hypervisor level protections. There are like a bunch of people who do that. Like for example, there's a blog called the Secret Club, and they do a lot of there's a group of people called the Secret Club, and they do a lot of like video games. I mean, you read their blog, for example, they deal with a lot with anti-cheat uh, to figure out to bypass those and then get where they want. Uh, it's a lot easier on the inside, I should say.
Got it. Yeah, that I just shared the blog post. It looks very interesting. It has like a, how RuneScape catches botters is one of the blog posts. They have things like escaping VirtualBox, which obviously definitely would lead you down the rabbit hole of being able to manipulate games, right? So that's pretty. Thanks for sharing
Yeah,
that.
there's a forum called Guided Hacking.
Sorry, could you
That
say that again?
pretty much guided hacking. Pretty much all they do is video games. If you go to the forums, you see like, oh, here's a cheat for this game. Here's how the traffic for the other game works, so on and so forth.
See, and have you actually found any of when you've looked at that forum? Have you seen anything related to some of the games you've been looking at?
I mean, PR games are there uh, because of because they're popular, I guess.
Got it.
So yeah.
You probably can't talk too much about that too. I get that. Okay, so that's great. So basically, tools like Frida are very good. Taking a look at other resources how people already hack games, and obviously taking a look at how that works is definitely going to help people. Let's move away from game hacking for a quick moment and talk about thick clients. So obviously, game hacking, people know what a game is. It's this executable that runs on your machine, and you can log into World of Warcraft, for example, and run around in a character. But there's this, on your website, Parsia.net, you have this very well-detailed blogs on how to test thick clients. So could you tell the audience what a thick client is, and just start with that? Yeah.
It's very hard to describe it, but a game is a type of thick client. A thick client is an app that runs a code on your machine directly and not through another platform. For example, if you open like google.com in your browser, google.com is a website, but the browser is a thick client. So your CPU is, well, I mean, that's the wrong thing. But most of the code runs on most of the thing directly runs on your machine compared to like if it's run through a different platform. It's hard to explain, sorry. If you know it when you see one.
Yeah, I mean, obviously, the way I like to normally say, obviously, yes, the browser is technically a type of thick client, but if you're using things like Slack at work, or if you're using any type of Electron application, that normally is what people would class as a thick client. I guess everything's Electron these days, right? So, so I want to just so you have this. I'll share the blog in the stream, which obviously it's a fantastic resource for testing thick clients. But can you talk about some of the methodologies that you normally do when, let's say, if you were trying to target something you found the vulnerability in the PlayStation thick client, which technically was this application that runs on your desktop and is related to the Sony to PlayStation. What is your general process when you finally you find an executable, you install that application, and then you start to understand how it all works? What is the general process for you there?
So the general thing I do is what I call attack surface analysis. So typically you have like in a normal Windows machine, like we're not talking domain connected or something, you have 3 privilege levels. You have a remote attacker, you have a local attacker that is not that is a standard user but not local admin, and then you have like local admin or system, right? So an attack surface is so and you it's a bug when you can escalate your privileges from one to the other. So if you're a remote attacker, you can get on the machine, it's great. If you're a local attacker, you can become admin. It's again great, but not as devastating as it sounds. Uh, so an attack surface is anything any of the first two can access that is related to your application, and then they can abuse it to become the rest. So for example, you install an application, it starts a local server. The PlayStation Now application was running a local WebSocket server listening on 0000, which is all interfaces. So if someone from outside could connect to that port, then they could escalate their privileges, right? They could get remote code execution on the machine, and then now we have found a bad thing. Any website that you open on your browser could do the same, regardless of, because it's a local WebSocket, even if it's bound to localhost, then it was a problem. One of the great things you can do, I need to write a bunch of blog posts about it. I haven't done so. I started, if you look at the last 3 blog posts, I've written 2 about like attack surface analysis. Like the first one is like update mechanisms, like how you can abuse an update mechanism to figure out to escalate your privileges. So this is a local attacker to, or a remote attacker to local. The second one is like URI protocol handlers. Essentially, you can run applications through the browser, right? Like, I don't know, Slack :// do something. And if you go in and click on a link, the browser says, do you want to like open Slack? And then passes a bunch of parameters to the Slack. So this is a way, this is an attack surface that an remote attacker can use to mess with your machine. Because if you go to their website and you click on the link and it says, oh, do you want to open Slack? And everyone is like, yeah, why not? I mean, what the worst that could happen?
Yep.
And then you get remote code execution, then that's bad. One of the things I would like to do, when I'm starting, is like there's a tool called Attack Surface Analyzer by Microsoft. So version 2 is on GitHub, and initially when it was released, I actually found a remote code execution on it because it's an Electron app. So there's another blog post about that. A while ago I said I only know like a single trick, and then it's exactly that. So what it does is it creates a snapshot of your machine. You can create snapshots, and then you can compare those. So before you install an app, you create a snapshot, and then you install an app, and then also there's some sort of monitoring you can do, but I don't use it. And then you install an app, you take a snapshot after it's installed, and you compare. And then it tells you like if it's opened any ports, if it's added files, if it's added registry keys, if it's added Windows services, if like scheduled tasks, all of these information, each of these are attack surfaces. Like if you have any scheduled tasks that normal users can run, it's usually run as a system privilege level. If you can run it normally and then you can mess with it to run your own binary, then you're good to go, right? All of these are there. So you make your snapshot, you compare those, you look at those attack surfaces, and you think of like how one of the first 2 privilege levels, a local standard user or a remote attacker, can abuse it to become one of the other ones, and then you go from there. There's also, with the thick clients, there's also like a huge server-side components, depending on the thick clients. Like, for example, video games are probably, depending on the game, right, might not be heavy in that regard. Like a single-player game has no server, so who cares,
True.
right? If you're playing Jedi Fallen Order, what is the worst you can do server-side? There's no server, right? It's a single-player game. If you're playing something like Counter-Strike, the server becomes important. If you're playing in like an MMO where most of the computation happens on the server side, well, hopefully, like if you're swinging an axe and it says you did 100 damage, that 100 damage better came up from the server and not your machine, right?
True.
So that becomes important. I have had success in bug bounties, big bounty, with just proxying a thick client. And there are like 11 blog posts about like thick client proxying, like how you can proxy different stacks on my blog.
Hmm.
And then looking at the APIs, often the APIs for thick clients are much more relaxed than the one for the web apps. Sometimes it's as simple as having a different API that's different. Sometimes it's the same API, but if it's like a specific user agent, then you can do things.
Yeah.
Uh, like I was reading about on the Twitter about some semantic um, thing that you could use to download files, and then the only way you could do it is you send a request with a specific user agent, and it would just do it.
Okay, that's a bug that I found a long time ago, where it would block iPads because like the way the UI was designed, like if you went to visit it on an iPad, it would show all the information it wasn't supposed to show. So they just blocked iPads. But then if you changed your user agent to be iPad, or from iPad to this, it was like allowing you to see everything, which was really funky because they were supposed to be like in-store stuff. So okay, very cool.
Yeah, like
Yeah.
a bit sorry for
No, you're
interrupting you
good.
with the clients, because there is a lot of code, and like mobile apps, because there's a lot of code running on the machines, the developers trust that code. It's like they have a higher level of trust with requests coming from a mobile or thick client than like a web app.
Yeah. So I've definitely reported bug bounties through just like taking a look at like the initial request for an app and then seeing that it like pulls out like a WADL or like a WSDL, which normally has the definitions for like a RESTful or a SOAP API. And then a lot of the times when you're like checking out these kind of older thick clients, like let's say like older Java ones or something, they don't need to be old, but most of the applications I see probably haven't been updated for a while. So I would class them as old. So like normally like those are like lacking authentication or authorization. So or are vulnerable to the common server side type vulnerabilities anyway. The one interesting thing I've seen in common thick clients is that it's very interesting because a lot of these applications are like polling to like move to the next stage of things. And a lot of the time like you can like forcefully like give the response to the client, which then once it receives a generic like it's all good, we've finally passed this stage, or move you on to the next stage. And that's very common for like most attacks that I've seen, from like things like authentication, from being able to bypass security controls, because they don't expect someone to make it to the third stage before they made it past the second stage, for example. And if that's reliant on the client to do some of those security components, it gets really interesting. That's how I have done some of those things.
Yeah, I have done some of those when I was still at Synopsys. Uh, the uh, yeah, so you change the response to logged in true, and then everything works. It's great.
Yeah. But sometimes it's a bit more complex than that, but yeah, like that's
Yeah.
really interesting. Like so, like just my general go-to is like if I'm testing an application, I also link the attack surface analyzer, because it's a really good kind of like starting place if someone is not entirely sure what's happening with an application. You also have things like Procmon, which I'll also share in the stream in the stream, that allows you to obviously take a look at all of the TCP incoming, outgoing TCP connections. So sometimes you don't know what the URL of the domain is. So like using something like Procmon, I'm sure there's also the sysinternal utilities as well, which I'm sure has probably that functionality too. But I generally, yeah, go ahead.
Yeah, so Procmon is my favorite dynamic analysis tool. If I had to like take one tool, I would take Procmon. It can pretty much do whatever. So it's part of sysinternals. If you're looking for things like network connection, TCP view, again, part of that does the job. Access check is great. You can check access controls for like named pipes, files, registry keys, so on and so forth. So every time you're accessing a file, you're writing to a file as a higher privilege process, where you can write to it also as a normal standard user. You could use one of James Forsha's tools. So he has two major tools. The first one is symbolic link testing tools, and the second one is sandbox attack surface analysis tools. Both are on GitHub. You can use basically one of his techniques to to escalate your privileges, and then symlink to a different file, modify it, have the service modify it, and then you have access. You have become admin if you want to.
Yeah.
So James Forsha's blog is pretty much half of what I know is either James Forsha's blog or Tavis or Mandy's blogs on the Chromium bug tracker. The Google Project Zero bug tracker is great, but I mostly look at James and Tavis bugs. Like the PlayStation Now bug was basically like 2 Tavis bugs mixed together. Like I did nothing new there, which
Nice.
is great for me.
Yeah, I think that's also a very good point, right? Is that you never really, sometimes, like most of the time, you're not reinventing the wheel to find these bugs because, applications are generally built the same. They mostly function the same ways. So therefore, most of the vulnerabilities you find, like let's just put like XSS as a prime example, it's normally the same payloads like that people are using because like all you're doing is just making sure that the HTML renders in a particular way for you to be able to get into a JavaScript execution. So it's the same thing like when you're testing clients or desktop clients and so on. It's like really interesting to kind of see those comparisons, and normally following like a workflow is pretty cool in that manner.
Yeah, like reading other people's blog and then like practicing is what's done it for me. But I'm not great at this, but I do some stuff.
That's actually what we're going to move into next. You say you're not very good, but there's this there's this thing called the Parsia Clone, and I'm sure you know what the Parsia Clone is, but the audience does not. So I'll give my interpretation, and then you can talk about the Parsia Clone if you wish.
Okay.
So at Synopsys, and I think it's fine to talk about this because it's just funny in general. There's nothing like sensitive. Parsia had this mission. We had like this very in-depth conversation for such a long time, and Parsia had this mission to make himself unemployable. Like he didn't want to be employed anymore. He wanted to put himself out of a job. So he built this thing, this giant repository, this monolith of things called the Parsia Clone. And he would basically, every time he learned something new, he would just dump this thing into the Parsia Clone. And if someone asked me like something about a thick client, I was like, just take a look in the Parsia Clone. I'm sure you'll find it. And lo and behold, they normally would find something like that. So can you talk about the Parsia Clone from your side and just kind
Sure.
of go from there?
Sure. So I started, I was getting so many questions about things that I realized I can just put all of this in like a repository, and I started it as a Git repository because you can write Markdown and link, and then the web interface renders it. GitLab, GitLab, all of them do, right? But then you can also do like better knowledge management things like Confluence or SharePoint or whatever, right? That does it for you. Then I realized, well, I can put all of these somewhere. And then when people ask me questions, I would send them a list. And the list was basically like, I forgot what the actual name was. It was like uh, State of Divinity or something. I'd given it like a silly name. It was like 7 things you need to do. Like, did you Google it? Did you search in like SharePoint? Did you search in like Parsia Clone? Did you search X? Did you ask X person? Did you search this mailing list? So on and so forth. And then I would send it to people and be like, oh, have you done this? If you've done this and you haven't found the issue, then come to me. I'll help you. That helped a lot in like reducing the number of questions. I mean, it sounds arrogant, which unfortunately is, but at some point you gotta, figure out if you want to do your job, better answer questions. Uh, and then I started putting everything I know there because I realized like I can't keep everything in my head. I have to just write down everything I know because otherwise like I will forget. And it's not just it's mostly for myself because every time I don't memorize things anymore. So when I was looking for my current job, I was doing an interview, and then person asked me a question, and I said, "Well, I don't know exactly, but I've written about it. Here's what keyword you can search on my blog to find a blog post about it." Uh, so instead of just answering, I would be like, "I've written about it. You go read it." And not everyone likes it, but my boss at the time who was interviewing me loved it. So it was great. Um, then I read a blog post by Tom Limoncelli. It's called Manual Work is a Bug. If you search for it, there's an ACMQ article. So Tom is the head of SRE for Stack Overflow, and before he was at Google. So he was the person who was an SRE before people started calling themselves SRE. So he basically has a thing that says, well, everything you do, every manual work that you do should have a goal. And the goal is to automate it, to automate that task. And the first part of automation, and there's a different steps. The first part of automation is writing down what you're doing. If you do a task and it has like 5 different steps, write it down. And it doesn't need to be detailed. It doesn't need to be completely automated with scripts and all. You just write down the things you do. Next time you do the task, you go through those steps and then refine them. If the steps are wrong, if there's something you added, and then you put it on Confluence or whatever. And then other team members come in and do the same. So after a while, it becomes like kind of sort of like it becomes like second nature. You don't need to remember what the task was. You can say, oh, if I need to do X, I can go and find these steps. And you just do those steps and it works. If it doesn't work, then you figure out why it doesn't work and update the documentation. And there are like different levels. The final level is being like a self-service web interface where like you don't have to do the task anymore. If someone wants to do it, they go and like do it, like a password reset. No one does manual password reset anymore, right? You go to a website and then just do a password reset for yourself.
Yeah.
Uh, but yeah, but one of the key things I learned is that I need to document everything, and two, not everything needs to be completely automated. If you can like just write down those steps to some extent that is good enough for you, you don't need to create like a self-service account, a self-service website for something that you do yourself, right? You don't need to do that.
Was that the part? So I remember you releasing a blog post comments report like around the dark side of manual work is a bug. And was those the core parts, or what were some of those things that you documented? And I know you may need to look it up. It's been a while, but
Yeah, probably have to look it up. But I remember like the major takeaway was that I just started at EA, so I was writing a lot of like processes, workflows, and everything that I had to do at EA. So it takes a lot of time. That's the major takeaway. That you need to spend time on it. Your actual task will be slowed down. It's not as great as until you get to like a space where you don't realize all the time gains until like some time has passed. So it might not come in. You might be slower than a person who doesn't do any of that for the first 3 months or 6 months or whatever.
Mhm.
But you will get there. So that's the dark side of it. You need. That's the thing I remember is that you need time to do all of this.
Got it. Yeah, I mean, definitely time is always a sinker, and some people may argue along the lines of, if you need to do it once, you probably don't need to automate it. But I guess time and time again, like I always think I only needed to do this one task once, and then 6 months later or 3 months later, I would need to go and relearn the entire process because I didn't document it, for example. So yeah, I can understand like the benefits, but also potentially the concerns around like automation and manual work as a bug, etc. So
Yeah.
very cool. So let's move on to like tooling. So you've done also tooling to try and simplify workflows. So you released a tool called ESLinter, and if anyone doesn't know what ESLinter is, it's a like ESLint itself is it's a JavaScript linter which does like semantic analysis to find common issues inside code. And Parsia went extra over this to basically, I was just trying to find the link, to automate this in a web testing manner. Can you talk about ESLinter real quick?
Sure. So I remember you linked the blog post for me. Jacob had created what is called a blog post about how he had extracted JavaScript from like web pages and then ran a bunch of ESLint rules on it and found like DOM XSS, I think it was. Then I talked to him about it and he was like, yeah, that's a great thing to do. And I'm like, oh, why don't we automate it? So I wrote a burp extension that I haven't updated in a while, where what it does is you set some stuff up. There's this pretty complicated Gradle task that creates a config file for you. It's like so many configs. You browse the web through Burp, the browser website, it extracts JavaScript from the pages and like embed it into the page, or like JavaScript files, so on and so forth, and it runs ESLint on it with a set of rules that you have decided you have, and then the results are in Burp. I didn't, on purpose, I didn't do a create issues uh, functionality put it, because otherwise it would have become a pro uh, extension. I don't want a pro extension. I mean, I have like Burp personal and at work, whatever, but like I don't want people to have pro to use the extension. Then it runs it and then does stuff for you automatically. So if you have like these very specific rules that you know can find good things for you, just run the extension in the background, and then after a while you go and see if it found in something. And if it found, like, you haven't lost a lot of time, like you have lost 5 minutes setting it up. If it makes you like $100, that's worth it.
Yeah, it's also like saves you a lot of time. So like I would find ESLinter, like, or ESLint in general, very beneficial because the people at Mozilla, they created this no sanitization rule, which basically finds any type of inner HTML assignment which isn't a literal string, so it isn't in single quotes. And using that with ESLinter, which is automatically scanning the pages you're reviewing, could actually be very beneficial to find points of interest. That's why I like it. I've been trying to find it, but I can't seem to find it, so you may have to link it to me, Parsia, at the end, which is fine. But I can definitely share the no sanitize. So what I want to move on to now is that you built this tooling for like JavaScript analysis, like to try and find bugs in code. But more recently, you've been looking at things like Chrome extensions, and you've also been looking at trying to do reverse engineering in more complicated kind of scenarios. So do you want to jump into the live demo now and just kind of talk about the types of things that you've been doing?
Sure. Let me share my screen. What is this?
Yeah, good. We're good.
Sure. So I was looking at this tool called Nordpass Password Manager. And then Nordpass Password Manager is like your typical password manager. Just run it. It's an Electron app, actually. And
so like definitely some funky stuff going on with this, but
yeah. And let me just random thing. Yeah, so some just random stuff. Whatever. None of these are actual. And then it has a browser extension, which does the autofill and all that funky stuff, because the passwords are on the machine, the app, and then there's a password, there's extension that does it for you. And I want to look at the extension, and I couldn't find a guide that tells you how to test a browser extension. 100% sure other people have done it. There is like a ton of it.
Yeah, there is one thing from, I believe, Mandatory Programmer, and he built a Chrome extension, or a tool that will look at vulnerabilities, or like try and identify vulnerabilities with password managers. So using intercode features, etc. So I'll share that with the stream, but you please continue.
Yeah, like in general, I couldn't find like any guide that says how do you manually test a browser extension, not just password manager. I found like 2 automated tools that the app gave extension to it, and they would do like check like permissions, so on and so forth. But anyway, so what I'm going to do is I'm going to show how to test one in Chrome. Fortunately, I have only 20 minutes, and this is something that would probably take a couple of hours, but I'll just skip a bunch of stuff. So we go to the page.
If we can go a little bit longer as well, by the way. If you have to jump to a meeting, that's fine. If not, feel free.
Okay. So you go in and install the app, and then first time you install the app, the Windows firewall thing pops up. It says, "Oh, do you want to open it? Do you want like add a rule for this app?" And every time you see this, you know that there's like opening a port, because it's listening to something. So there's a local server. So the first thing you do is like, oh, let's see if there are any local servers. Windows terminal. Sorry, terminal. I'm just running it as admin, and you're trying to command like netstat a and b, and then you like I don't know, Nordpass text, right? Now the problem with netstat, if you look at when you look at the output, it's shows the process. That has created the port and is like listening and created the connection,
Mm-hmm.
but it's in a different line. So if you do like a find string, it just doesn't do anything. So I have to like manually look at it. So if I do something like find str spin like Nordpass, it just shows me that, oh yeah, Nordpass is running, okay. But it doesn't show me which port because everything is like a different line. So I have to manually do this. There are like PowerShell stuff that does it for you, but I like netstat because I like to manually look at this. And then we find this. It's running on, it's running something on like port 9213. So we're like, okay, what are we going to do? Next thing we do is we run Wireshark and we say, okay, I want to look at the local traffic, which is the loopback interface adapter.
Mm-hmm.
And then here's a filter, tcp.port equals 9213. And then now everything is in that is going to be captured and there's nothing happening. So now, so we're going like, okay, let me just install the app and see how it works. So if you like add to Chrome, it says yes, it says it does some stuff, and then suddenly this pops up. It shows you like a 4-digit code.
Mm-hmm.
And then this is from the actual app, the desktop app, the Electron app. And you enter the code, they're now paired.
Got you.
And then let's go and look at the traffic, right? So I'm skipping like a bunch of steps. I'm just going to the font and the traffic, and I'm like, what kind of traffic are we looking at? And the moment you see something like this, you know that it's like a WebSocket connection.
Mm-hmm.
I mean, you can also do this. But the moment you see this, you can see a WebSocket connection. This is the initial handshake for WebSocket connection. And this is the response that says 101. The first thing we need to understand is like WebSockets are not bound by the same origin policy. So any origin can talk to any other origin through a WebSocket connection and then send this request. So it doesn't really matter if you have CSP set up, course set up or not. It doesn't really matter. They can always do that. So then we look at some of the traffic going on. So this is the traffic from the extension to the server. Let me copy this into a page like this. So this is like a JSON blob, which is really great because it's probably they use JSON stringify. It's a packet going on, and there's ID, and the type is extension login, and then you have this large hex thing that says key, and there's like an extension ID, which is different from the extension ID in the Chrome store. So Chrome Web Store expression ID is this one.
So let's just recap for a second. So you basically realized that this application was running on a local web server using netstat. And then obviously you set up Wireshark to basically see any communication happening with that particular port. And then because you didn't see any traffic happening, you then essentially just installed the application and utilized it. And then you started to leverage and see that information occurring.
Yeah. So if you, this is the first one coming from the client, coming from the extension. And then the server responds with something very, very similar. Again, extension login key, which is some hex blob. And then this is where the 4-digit thing pops up. And after you do that, you see traffic like this, which is again encrypted. How do we figure out if something like this is encrypted? When you look at it. So for example, you have a bunch of blobs, and then you go to like CyberChef.
And CyberChef is like a Swiss Army knife that allows you to take a look at different type of encryption types, or like if it's encoded or if it's in some type of format.
So essentially what I do is like I do a hex dump. I'm sorry, I have done from hex and then to hex dump. Every time you see something like this that has like high entropy, it's either encrypted or compressed. Compressed stuff usually like have a bunch of like magic headers here, like a dictionary, so on and so forth, or just a bunch of like magic bytes that you learn as you see them. This comes with experience. So if something starts with 789C, it's zlib. 78 something is usually zlib. If it's like 18FB, it's like inflate or deflate. There are a bunch of like these magic headers that you can search. But in this case, it's encrypted because it's none of those. CyberChef also has a magic thing that is not really that useful here
Yeah.
because it doesn't.
But it might be able to,
and
like, basically automatically get rid of like base64 encoded, then into something else, etc. So it might be able to magically do that, right? And how far the depth goes is probably also important here too.
Yeah, so I think it's a recreator of the magic Python utility that they have recreated in JavaScript. Basically, if you give it a large enough blob that is in some format, it tries to figure out like those magic headers and all that to figure out what it is.
Got
But
it.
this is like small and like doesn't make any sense. So I don't know, what is this? I don't know. So it's encrypted. Okay. So we send a couple of what they call keys out, and then we get encrypted data. So that means we are doing some sort of like cryptomagic out there. So how do we start testing an extension in Edge, which is the same in Chrome? It doesn't really matter. So first thing we need to do is we need to figure out where the extension is. We want to find the source code. So on Edge on Windows, it's at this location. App data, local, blah, 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 blah. You can Google it. It doesn't really matter. And we already know this is my extension, so I'm just going to copy it, put it somewhere, I don't know, here, right? And then what we can do is we can like open it in VS Code and then look at the source. Every time you run an extension, the first thing happens is the background.js file opens. And this is minified. And there's a map out there somewhere that we don't have access to. Like autofill, you can look at it. They're all the same.
Just if people don't know what a map is, it allows you to get back to the original JavaScript. So it's like a source map, which allows you to be able to re-reference everything and get to the same old structure with the correct folder locations, the correct JavaScript naming conventions. Like it's beautified, etc.
Yeah, great. So next thing you want to do, you want to use the browser dev tools, which are really great to debug the JavaScript of the extension. So the way you do it, there are different ways of doing it. The way I do it is that, so first you have copied it, so I'm going to remove this from the file, and then it's gone. So why did you install it? I don't care. Now the first thing you do is you enable developer mode, which is here. Chrome has the same thing, and probably in a different location in the same page. And what you want to do is you want to click on load unpacked, and then point it to the file that we copied, the directory that we copied out there. What you want to do is you want to point it to the innermost folder that has the file called manifest.json. So in this case, it's under this 32911. So if I choose this one, it says, oh, I can't find it because manifest.json is not there. What I'm going to do is I'm going to choose this one. And now you have the extension. And because it's a new instance of extension, it does the whole cryptomagic thing again, which I don't care for now. Now what you can do is you have this thing now that you can click on the background page. It opens the DevTools. Welcome, no. And then you can start debugging. And because it's minified, it says, oh, it's source map detector, we don't have it. You can pretty print it, right? And then you can do debugging normally similar to like a normal extension, normal browser JavaScript in the browser that you can do. Put breakpoints, put watches. It's very powerful. The dev tools are very powerful. So I'm not going to go into it.
Yep.
What we want to do is we want to start reverse engineering this blob to figure out what the app does. And the way we can do it is we want to do it in VS Code. So we already have the extension open in Visual Studio Code. What I'm going to do is I'm going to first beautify it, because the pretty print in the browser, we have to do it every time, and it's not great for editing. And then use the VS Code symbol renamer to figure out what each part of the JavaScript does. Exactly. And again, this is something that I couldn't find out outside. Like I've never seen anyone do it. I mean, people have done it obviously, but no one has published anything. So first thing we do is we want to run a beautifier on it, and then you have there are a bunch of stuff out there. There's an npm package and also a Python package called JSBeautify that does it. There are online beautifiers, but I usually don't like to pass things to online stuff because
who knows what's happening in the back end.
Yeah. So what you do is you do -r start.js. -r does a replace, and start.js pretty much just changes everything, beautifies everything that is that start that says a JS extension. It doesn't unfortunately go recursively, but it doesn't really matter in our case because we are doing that. And now we only care about background. And now we have this beautified. Now we have a bunch of blob of JavaScript, and we don't know what it is in there. Um, so when you see a file like this, it's a bunch of like modules put together. I honestly have no idea what what this name of this method of obfuscation is, or like minifying is. I don't know everything. I've learned this like practice, trial and error. So when you see something like this, a bunch of JavaScript all together, and there are two types of stuff in them. There's like open source stuff, which is the majority of it, and there's like custom application code, which does what we want to figure out. What you want to do is if you see things like this, you want to figure out what this module is and start renaming the functions, because the functions that you rename are probably used in the custom app code. So when you get to the custom app code and you want to reverse it, you have those functions. You know what I does, for example. So one of the things I would like to do is to look at strings that are kind of sort of unique. So in this case, I have this, let me remove this. I have this string that looks very unique as part of function I, and I want to know what it does. What I do is like, I go to, I don't know, either go GitHub or like to go to grep.app, which is an app that indexes GitHub. And then you're like, oh, I want to look at this. And it turns out that it's out there. So how do we figure out what is what? Let's open like this one, see what it is. And then we search for it, and we end up here, and it says UUID. Okay, so this function is a UUID function, but there are like different ways of finding UUID functions. One of the other things we figure out is like you see strings that show you what kind of module it is. In this case, we like have like Sentry original. So Sentry is like I have no idea what it does, but I've seen it in modules. Like it's like a logging, aggregating thing.
Yeah, it's like analytics, I think.
Yeah.
Yep.
So if you go back to the previous page, grep.app, there's one for Sentry, right? Get Sentry misc.typescript. And you're like, okay, let me just open it. And it's on GitHub. And then we search for it. And let me do a
pretty similar to what you've just been showing us too, right? So the thing you just used was grep.app that allows you to, take a look at lots of GitHub repositories to try and find similar things, which actually is really cool because, if you're just looking at minified stuff all the time, you're going to lose your mind. So trying to put it back into the original format is huge.
So basically, it's the reason we have found a lot of it is that because everyone has copied something from a Stack Overflow.
Yeah.
So there's a bunch of like ESLint. Remember we talked about ESLint? These are directives that tell ESLint not to alert. So in here they are doing like bitwise operations. Sorry, go ahead.
No, I was just saying like normally like when you try and like run a npm script or something, you'll run like ESLint in the background before you like either push to production or something, and that you would disable these so you can just make sure that it's not warning you as it's going into like either your builds, etc.
So what we can do is we know that this function does is UUID4. So what we're going to do is we're going to press F2, and this VS Code has this symbol renamer, because it basically says what this function I with this in the AST with this type, then I can rename it. So this is also highlighted. And I can rename it. I can say, oh, it's UUID4.
So you pressed F2 here.
Yeah.
Got it.
And the symbol renamer kicks in. And it's for different languages other than JavaScript and TypeScript, you have to install like a extension, the VS Code extension for it that installs like a language server. So you can pretty much do the same in like C# or C++, everything. Every popular language. But JavaScript and TypeScript support is like built in. So like, oh, UUID4. Of course it's not. So I don't care about this. So it's now UUID4. If we go a little bit here, we have this too. const global is get global object. E equals R. So R is, what is it now? Get global object, right? And E is now global. One of the things it does, it doesn't check if there's already a variable in scope um, with the same name. So I usually just to try to do something like this, so that it doesn't conflict. Like especially with global, which is like a keyword or whatever. I don't know JavaScript does that. Second thing I would like to do is I would like to.
Sorry, I was going to say like that might be a good way to, when you're doing this type of thing, like just keeping like a reference to know what exactly has changed and what was the original. So that's probably a good practice in general.
Yeah, and then another thing I would like to do, because you are going to mess this up, and then when you reload the extension, it will not work. You will have errors at the end of the file because of the formatting. So one thing I would like to do every time I do it is I create a Git repository here, right? Git init. And then every once in a while, after a few changes, I reload the extension and check if it's working. So you can go back to Edge, right here, and then reload the extension. And if it's working, it's working. Then I do a commit that says, oh, this is working. So git commit, I don't know, dash, I'm sorry, git add. Who cares? Git commit dash UUID changed, right? So every time you have to set these up, it doesn't really matter. Every time you go to a state, after a few changes, reload the extension. If it works, you commit. And if it doesn't work, instead of spending time figuring out what it is, you just go back to a previous commit and just do those changes again. This time more careful.
Very smart.
So that's one of the things I would like to do. So anyway, so these are like old open source stuff. So we can find the actual source. Sometimes we are more lucky and actually find like an exact one-to-one. In this case, it wasn't, because it was a TypeScript and this is JavaScript, transpiling, whatever. But usually we can find the actual thing. And then you just start searching for these and it works. But we want to find the actual application code, like where this crypto thing happens. So what do we do? One thing, there are different ways of getting there, but the thing I would like to do is that we already know the port. So we search for it, and we land up here. So this is like ports, right? Then x is 0, and then grabs x of 0. So current port, right? And then this is get current port, right? You can start changing this, and then you see like functions like this. You don't need to know how exactly it works, but looking at the things you've renamed, you can probably figure out what it does. It checks first port, waits for a certain amount of time, checks the second port, so on and so forth. So you can imagine the desktop application does the same. If 92.13 is occupied on your machine, and then you chooses a second one, third one, and fourth one, and then goes through all of it, and then you can do that. So now we have landed in the actual application code. We can see a bunch of like encrypting, like subtle crypto is like these web crypto API that is super interesting, and then you can find it on MDM to figure out what something does or not. I would have loved to go through everything, but I'm just going to skip a bunch of steps and then tell you what happens. So we found two keys going around, a key from the client and a key from the server, and then encryption started happening. So every time you see asymmetric cryptography and then symmetric cryptography used together, what is it? Like TLS does it. Use asymmetric to agree on a shared secret or exchange a key. And then you use that shared secret to do symmetric encryption like AES or whatever. That's literally what TLS does, and which is what is happening here too. So what we're going to do is we're going to see if we're gonna look around and figure out what's happening here. And again, I'm skipping a bunch of steps, but anyway, we get to this place, and there are two objects. The first one is ACM AES GCM, and then second one is ECDH and Curve 384. They're like think 4 or 5 standard curves. The 3 of them are implemented in subtle crypto, 256, 384, and 512. I don't know exactly. And then these are used in different subtle crypto functions. So when we already know, we've figured out that they want to create a shared secret, right? So if we go and search for shared secret in subtle crypto, shared secret, we found a bunch of like APIs on MDN. And MDN is great. So we have derived key,
Really agree.
and we have derived bits. So we look at derived key, and basically we already seen ECDH, right? So what it does is, the way it works is you elliptic curve Diffie-Hellman works, is that you use your own private key and the other person's public key to generate a shared secret. And then you have agreed on one. That's literally what the algorithm does. And then you can use it in 2 ways. You can use derived key to just literally get a key that you can use in something else, or you can use it to derive bits, basically an array of bytes that you can use to generate a key from. So in here, we see derived bits. So what we're going to do is now, oh, it's already there. Oh, that's fun. It's already there. The first one is algorithm. Then it's just this object. So this object that assign whatever is basically just passing just adding stuff to it. So we know that, what is this? This is called ECDH algorithm, algo, and this is AES algo, right? And then we go to derived bits and be like, okay, this the first object is an ECDH algo. We go to the here and be like, oh, the first one is algorithm. If you're using ECDH, you need to pass this. We go here and it says, okay, so this is an object with 2 parts. The first one is a DOM string that says ECDH. The second one is I'm sorry, this object has 2 fields or properties. What do they call them in JavaScript?
They're properties. I mean, you can call them fields, but yeah, they're normally properties.
You can understand like how much I know JavaScript. So the first one is like, there's an ECDH, and the second one is the public key, which is coming from the other side, right? So we go back to our thing and say, okay, the first one is this object that we saw, and then this is the public key, server public key from this extension, and then we rename it. And then what we're going to do is the second one is called, go back. The second one is base key, which is your own crypto key, right? So in this case, what we're going to do is extension key. So this is, see, as we renamed it, this also got renamed because so it's a function that generates it. So it's one of the, and then the third one is 384, which means to create 384 bytes. All right, so what is this? This is, we can just call it shared secret. And then what is the shared secret used? Here it got changed, right? It's used in digest. This is basically a hash, a SHA-256 hash, right? You can see this in stack. So what they do is they exchange these keys, they generate a shared secret, which is 384 bits, and then hash it to get 256, and then this is the result of the hash. I honestly don't know how most of this works, but like the hash is the parameter for this function, and this function is basically converts it to a uint array, and then essentially what it does is it's used in this import key function to create an AES key from. So we can rename this to generate shared secret, right? And then what we can do is we can just click on this and press F12. It gets up to other usages. So we can see the generate shared secret is used in a different place. So this is the shared secret, the AES key, and then use the AES keys exported on here and then converted to an int array and then converted to hex and then passed out. And then store does something to it. What is this? We click on it and go here. This is basically just local storage. so on and so forth. So sorry for skipping a bunch of steps. We go through this, we look at these crypto functions, you keep pressing F to rename it, and after a while you have something that works, something like this. Let me just do sheet, and here, just sheet.
Does this mean you're also going to be releasing a blog post on this soon?
Yeah, I have a blog post. I'm just waiting for them to say to either figure out what they want to do with the something that I've reported or not, but I'll just do the blog post. And then finally you end up with something like this. Oh, I haven't changed it, have I? Where's the actual thing I modified? Oh, sorry.
You're good.
Wasn't here. Original, not this one. Nordpass, maybe it's here. Yeah, there we go.
So let's just recap real quick. So you essentially looked at things on grep app to try and find common references so you could easily update open source stuff. You then identified different references to like common utilities that exist in web browsers, such as subtle crypto, and was able to utilize the information on the documentation to be able to rewrite some of the stuff. And of course, you know, realistically, if some of that stuff may have been arbitrarily happening inside this code, you would be trying to find the references inside these JS structures and doing the same thing.
Yeah, and then the second thing I did is I want to instrument the app. So what I did is started going around and started putting console.log messages. Like if there's a message going out, I want to print it before it gets encrypted. If there's a message coming in, I wanna get it that is coming. Like this is where the AES key is generated. I want to see it. And then so on and so forth. And then next time you load the extension, let me just remove extension. Not this one, not this one. I'll remove, and then add my own. This PC, desktop, pass. This. And then when you open the browser console, or this, there we go. It prints all the messages. Let me redo the extension so we can see everything. Reload. And then 6540. And for example, I found how this 6540 comes from. So basically this, like, and then the AES key in hex is this one. You can find the password, and then these are messages that are going out and coming back before encryption. This was great, but one of the things I wanted to do, and I think this was pretty cool, is that I wanted to send arbitrary messages. So what I did is I started adding functions to the code. That to send my own messages. So I already have found the send message function. So what I do is I just create my own function, and just so I can pass raw messages to it, and then you can send it out. So one of the things I had forgotten, and took me like an hour to figure out, is that I hadn't initially added it to the global scope, so I couldn't call the function from here. But when I did this, what I can do is I can send my own message.
I see.
Send me.
Smart.
Oh, send me is not defined because maybe I need to oh, because it's send with a capital. This one. See, now I can send messages going out, and then I can see what message is coming in for its as a result. So instead of like messing with the extension to figure out what it does or create my own extension, or just instrumenting it, then I can like export any kind of functionality I want like this, and I can just use it in the browser console.
That's really cool.
Which is pretty cool, I think.
So like that's basically like you do enough to understand how the application like fully functions, and then when you have a pretty good grasp of how it works, you can then start to instrument it to try and do malicious things like send malicious requests to the server. And I'm assuming this is going through the WebSocket.
Yeah, this is all going through the WebSocket. I'm not creating my own extension anymore. Yeah. Just so for example, this one, like this is like I can make the settings open. You can do some stuff that the extension can tell the browser to like open certain parts, the app. Like for example, here, let me redo this. There we go.
Nice.
Settings opens.
Nice.
So you can do some sort of like, you can talk to the desktop app and tell it to do some things too.
And obviously this doesn't lead to a direct vulnerability, but this could take you on a path of like, once you understand how this stuff works, they might be allowing additional arguments or like evaluating things in an insecure way, which could lead you to being able to send a post message of some kind, depending on how you can interact with this application, right? So that's very interesting. Awesome.
Yeah, so I basically mess with the extension as much as I can, and then see the this is the extension, so you can like see everything. You can, for example, if there's a way to, if your vault is locked here, you can try to open it from here. Basically, you could try your password here, and it sends a request to the app that says, "Oh, it's not locked." So if I want to like lock it, basically what it does is it's one of these. It locks the thing.
I can see like a user/lock.
User lock, yeah. So I can user lock and user unlock. And then inside the extension, I can say, oh, I want to unlock it. So 1, 2, 3, 4, 5, 6, unlock. Does it work? No. So it's basically this one.
Got it.
This message. You can do this message too. You can basically send this request, get the email, and then try to unlock it yourself if you want to.
Okay.
I don't know if like this gets rate limited, or I can just brute force it from the extension. It will take a while, but if you have your browser open, then maybe it works.
That's cool. So like the renaming stuff I didn't even know existed in inside actual Visual Studio Code. So that's a new one for me. And then creating your own functions is quite nice as well, because obviously these things don't do integrity checking of modification. It's just JavaScript that is running, and you can obviously modify that JavaScript however you wish. So that's so you could obviously modify these extensions to try and do malicious things. You can understand how they work, and yeah, that's really cool.
Yeah, it took me like an hour to figure out I need to do this. I need to add it to the global scope, whatever it means.
Yeah, it's just allowing yourself to access it, from a global property, because I think these Chrome extensions or extensions in general are isolated these days. So you would have to, I believe, expose it out if you wanted to be able to easily access the functions. Yeah.
Okay.
Cool.
Yeah.
Right. So let's. I think that's a really good. I think that's probably where we're probably going to end this component. So let's just jump back into the. Do you mind just canceling your stream? Thank you. And then let's jump back to lock screen. So I think that's probably a good place to stop. Obviously, I think you've showed a lot of interesting components there into how, browser extensions work. Obviously, not to like the best of, how they actually function at a very fundamental level, but, taking a look, like basically being able to go to that folder where the extensions live, which is very Googleable. It's all the same file structure for everyone. Being able to take that code and make it, readable through beautifying. And obviously it's not 100% readable because it's still minified. But then, using naming changes to be able to, access and understand more about how the functionality works. And obviously leveraging some tools and resources to try and get additional knowledge. I think that's kind of, it's a really, I really appreciate your time today, Parsia.
No problem.
Thank you for coming on. Yeah, so thank you for coming on. This will be on YouTube as well, so if you weren't able to check out the entire stream, we'll upload this to YouTube in the next day or two. And again, Parsia, thank you so much for coming on. This was a great learning experience for myself, and I'm sure some people who are watching this today or on the VOD as well. So thank you.
No problem. Thank you for having me, and thank you everyone for watching.
All right, thanks everyone.